It is cold today and I'm wearing my sweater. Just trying to keep warm while I try to do this video. It's cold. It's been nice and warm the last 3 days, and suddenly it got real cold. So here we are in the shop. We're talking about big block Chevys, and all this explanation here applies just as well to other engines. But the reason I'm talking about the Chevrolets, I have one of the versions sitting right here on the back. But we're going to talk about the basic head, which is this, and what are advantages, disadvantages of them, and what a much modified aluminum head is. And I'll bring it closer to the camera later, and you guys could see how drastic things are back then. What we had to do, including myself, to try to get power, because, oh my God, in the 1980s, there's no such thing really as CNC heads. Maybe the big guns in NASCAR, or I don't know, Pro Stock, maybe not even. Then if you have one guy that made good cylinder heads for the local racers or the divisional races or whatever it might be, they will be way above the rest. Today, if somebody has a good cylinder head for sale, they digitize that thing and they make hundreds of them, sell to everybody else. So back then I was competing with a handful of guys. Now you're competing with a bunch of guys. It's just not about the cylinder heads today that's being sold just about to everybody else. But money is the biggest equation. Back then, I bet you Glidden and them guys, Warren Johnson, they didn't have that much money, but they dominated, just sheer hard work and understanding the details that put them above the rest, way above everybody. And we'll look at that and what went on with this kind of cylinder heads, what we had to do back then, weld the whole thing and change the angle, and what happens to the pistons. And I have some pistons here that we could look at it, and we've come a long way. We've come a long way. Oh my gosh. But anyway, here we go. Big block Chevy. Now, everybody built this. It's kind of hard to beat. But one defect, I can say it's a defect, and they're not really thinking about airflow back then when they designed this thing, except maybe they knew that canted valve heads is the way to go. Across the lift spectrum, a canted valve head, since it opens up away from the cylinder wall to a certain extent, they pick up airflow through the middle. So you can have a cylinder head that flows a wedge, like a 440 or a 426, 428, 390, Ford high port, or tunnel port. All those things are impressive. But against a canted valve, they may reach the peak, same airflow numbers, but mid-lift flow values out of a canted valve head is kind of hard to beat. But anyway, here's the big block Chevy. The port goes like one, the outside port, guess what it does? Here's the direction of the path, the flow path. It runs straight to the wall. So you got a lot of shrouding there, and when it hits it, a lot of motion gets going right there. And this other one comes in, the inside port comes in and kind of slide into the exhaust and out. This one here goes this way, and you hope it turns this way, okay, from where I'm standing counterclockwise, and combust. The spark plug position there is not bad, considering it's pretty high up. So when you have a dome, it's not really affected. There's a closed chamber one. That's an open chamber. Now, on the other inside port, it has the same as the outside port issue. Carburetor right here come in, and it does a turn, a mild turn, but it's a bad enough turn, and run into the wall. And on the end port, if the 4 barrel is right here, the barrels and the plenum, it come in and straight out into the exhaust, and out it goes. When you look at this thing, how they process and how fast or how effective they burn the mixture in the chamber would dictate how much power they eventually will make. Because if you have a bad burning combustion chamber, I don't care if you got a lot of airflow. If it's not going to burn it effectively, it's not going to produce the power that you're expecting it to produce. So there we are. That is the basic, but you got 219, 224, 225 valves. So here's the, man, this sucker's heavy. Here's the intake side. And here's the intake side on this much modified head. Now, when you look how they differ, is that this is the typical overport, low performance head. And there's the high port. Now, what you're looking at, it's been kicked up quite significantly, and epoxy was laid on the floor of the port. A lot of epoxy, a lot of welding. Now, we heard a lot of people through the years go in and then they go, especially the jet boat guys. Man, I had a rectangular port head on my big block Chevy or big block Ford, and they put the standard 460 head, or they had the rectangular port and they went to the oval port. They picked up power. Well, they would, because their compression's not that high. So a lot of these guys are probably running 9.5, 10 to 1 max. Of course, this is not going to respond with that low compression. This would. Same thing with a big block Fords. When you have a CJ, Cobra Jet, and all that stuff, and then they put in the standard passenger head. And they go, hey, now it runs so much better. Well, I believe it. You got to match the compression to the cylinder head. Okay? Because if you got a good enough compression, 11.5 to 1, 11 to 1, then it's not quite as susceptible to too much port, especially when you're running a tunnel ram with two 660s or 600s or 750s. That's what everybody's running. These things respond well on a mild combination. Now, let's go back here. This has been kicked up, and if you notice right here, there's a lip. That's not on this head. The reason for the lip was the head. The whole surface was welded, filled up, and remachined again. The reason for that is if you kicked it up, what happens is here's the port, here's the combustion chamber, like here. When you kick up the port, you decrease the valve angle, and when you decrease the valve angle, the combustion chamber gets closer, and then it doesn't need as much of a dome as is really necessary, and you maintain the compression ratio, or actually have more compression with a smaller dome. So the reason for this was they welded the surface, built it up, and kicked it this way. Okay? Kicked it that way, so it decreased the valve angle. Now, that's the intake side. Now let's look at the chamber side, valve cover side. And here's where you're going to be shocked. Look at the amount of welding done right here. It's got offset guides to take the valve away from the cylinder wall. Okay, let me bring that closer. Here we go. Now you see it. The port has been welded here, kicked up, and epoxy on the floor all the way to the short side. Because when you start to lift it up, it becomes real thin right here. So what they did was welded up here, kicked it up, offset the exhaust, intake. The intake guys offset to one side. What it did was to take it this way and away from the cylinder wall. Okay? That is to give it, to unshroud it, give it a little bit more room here for air to pass by on the tight end of the cylinder head. And you can tell right there is the additional welding done to kick up the head this way and mill that side so it becomes a shorter, more compact combustion chamber. Now, when you look at the exhaust, here's the killer part. The port used to be right here. Well, used to be low, and it's kicked up quite a bit to decrease the angle. It's been filled up, lots of work, right there, okay? And usually they bust through the exhaust port, no big thing. It's a dry exhaust. Right there you can see the holes on the exhaust port. That's really not a problem. So the exhaust has been kicked up, and when we put it beside the standard big block Chevrolet, you will see how drastic this modification has been. Okay, this height was there before. Okay, same exact thing, but the way it's been modified, big block Chevy, same way. For everything, you kick up the exhaust, it makes it better because the pull of the exhaust is signaled or projected on the intake and gets it a good yank. So the intake port, even though it might be okay on the flow bench, but in combination with the exhaust port, that's its dancing partner. You can have a so-so flowing head. Now with the exhaust port, especially an effective exhaust port, it becomes a deadly combination. And you beat up on all those Fords and other Chevrolets. Okay, so here we are. There's the design element, kicked up exhaust. Now, let's put this big block on the side first. And let's bring this out. Now what we have here is a Pontiac Pro Stock head. There's no more welding needed. They did that already from the factory. That's why when the head rolled this way, okay, this one got closer here, and now you have a compact chamber. But look what happened. We have the left and right port. Look what we have here. All the same angle. Okay? Basically what you ended up with is a straight up port. What this chamber is doing is exactly close to what this is doing, this one, this one. Here you got different combinations. The left and right side port, I feel, I didn't run these things back in the day, but I feel that with the mixture motion going on here, that this left and right side port would have different timing requirements. It's how effective they burn against each other. And what I feel that they would have done, or I would have done if I was running it back then, before the age of computer, I would have taken off my MSD and all the magnetic things there. I'll bend each, and there's 8 of them for 8-cylinder. If, let's say, this one requires a little bit more advance because the swirl might a little bit lazier, maybe, then you start bending every other one. Either you back it up to retard it or kick it forward to advance it. So that is before the days of computer. I think that's what they've done. Just like back then, when I was running nitrous, NOS, Dale Vaznajan, and Mike Termas gave me my unit back then, almost for nothing when they were getting started with NOS. And I was running experiments even back in the day when hardly anybody knew knew what nitrous was. Would you believe I was leaving the line full on nitrous? They're going, how can you do that? It's hitting the line off the line. Yeah, I did. Because you know why? The solenoid, you know, we have the nitrous solenoid on the, and then the fuel solenoid right underneath the carburetor there. I would take my nitrous solenoid and kick it farther out from the plate. What that did is it made my car, my nitrous hit a lot softer, because when it's farther out, you have a, well, when they're evenly spaced on the plate, the nitrous will get there before the fuel. You know, you got a lot of pressure here, several hundred on the nitrous side, and you got what, 7 psi, 7.5 psi on the fuel side? Guess who's going to get to the plate quicker? Of course, the nitrous. So you have an instantaneous lean, and what the old saying, mean is lean, or lean is mean. Oh yeah, that sucker took off. Okay, so when I started, at that point in time, I consider nitrous as quick draw. If I can hit my nitrous a lot earlier than you can, I'm already way ahead. A lot of guys are waiting a little bit, then they hit the nitrous. They move up a little bit. No, I space my solenoid farther out. Okay, from the plate, and then I was hitting off the line. So I won the Muscle Car Nationals, the only one that won it with a small block. Everybody was winning with big blocks. And I was the only one with a small block that won the Muscle Car Nationals. And at that time, we all ran factory heads that you ported. Hardly anybody even has aluminum heads. Everybody had cast iron stuff. And anyway, that was one of my tricks. And then when I double stacked the plate, every time I engaged the second stage, it blew the tire just as much. So guess what? Both of my solenoids are farther apart from the plate. So when I engage second, it has a little delay, and then I'm hooked. It does the shift change. I hit the nitrous, boom. It did not blow the tires. So I think now these pro stock guys probably did their timing for the two different scenarios here in the combustion chamber. Now, as far as that is concerned, now let's look at the intake side. Look how high this became compared to this. All right? So back then, if you got a cylinder head guy that does a pretty doggone good job, he's going to dominate and you will dominate. Today, you can buy this. This is already outdated, but look how high this is. See that plate right there? It's already kicked up from the casting. You're looking at, oh my God, you know, two inches higher than this. So the angle coming into the valve is vastly different. You're gonna breathe deep. I think I took this to QMP because I put on my bench before, and that one had asthma after I read this head. So I took it to my console. I said, hey, flow test this for me. I think it had like 580 CFM out of this thing, out of this big block. That is impressive. I gotta look at my note. I think 580 or 560 CFM at 28. That's a lot. Oh gosh. Anyway, but here we go. You're looking at. Here you have all the fancy epoxy to try to twist the flow and wherever it's headed, they try to help it along. And the same canted valve arrangement. Still the same. Not much, but look what happened. There's no more welding. The port is real high. Okay? All this work. And then finally, you go to the exhaust. The ass cast exhaust. And look at that. There is just no comparison. Okay, guys? There's no comparison that will. All this work, might as well buy this, okay? And now there are other ones from CFE, and everybody else got way better heads than this thing. So that is a pretty good design change. Now, let's go back to the combustion chamber. Man, I'm making musical heads here. Now, the old head, which was this gizmo over here, had a deep combustion chamber. Okay, and this is even the the closed chamber one. The open chamber big block Chevy required a massive dome. Not only did you have the uneven left and right side port, which doomed it compared to the Cleveland Fords, which is this. That's why Glidden dominated, and Glidden was carrying more weight per cubic inch than any of the GM guys, even the Chrysler guys, or anybody really. And the Cleveland was strapped with additional weight penalty to try to get everybody to catch up. Why? The Cleveland Ford is basically the same as the big block Chevrolet, but the ports are all coming at the same approach angle, and they all peak. Whereas this thing here, it'll give you a broad power band because the other port will peak earlier and the other port will peak higher, so you got a better power band. Yes, but for all-out racing, you want them all to peak at the same time. And the Cleveland had that, even though it looked like a big block Chevy, but that in itself was such an advantage. But anyway, the early style big block Chevy, big combustion chamber, and this is the dome. $12.5. Look how it splits the combustion chamber in half. Okay? For the regular guy to go, oh man, look at the piston. That is such a radical design, you know, impressive. Now, here's what happened with a much modified rolled over cylinder head. Here is the piston. You see it? Compared to this guy. Big difference, isn't it? Big difference in the dome configuration. This is significantly lighter. Okay? Much, much lighter. And I've noticed that I rolled this over years ago. All right, to keep the flame to go to the other side because the spark plug is on this side, and I wanted to roll over the flame front. Here the guy who built it did not even put a slot on the spark plug recess. Okay, he did not even attempt to do that, and he has all the sharp edges. Things would get hot there. That's a big possibility, but hey, sometimes the devil's in the details. Okay, so one thing though is that what's interesting is when you look at this, you got an 043. I run an 043 ring pack on top. This camera would just focus correctly. I run an 043 and a 1/16 second. The 043 drag more on the cylinder wall because it has to seal with the gas port. Understood. But the reason I have a second thicker oil 1/16 is because I have a low tension oil ring and I needed to stabilize the piston from rocking this way. Okay, so having the thicker second ring, it doesn't drag as much because it has lower tension, but it has a lot more area to take the heat from the piston, transfer it to the cylinder wall, and get my cooling, my piston cooling more effective. Because the 043, the piston will tend to run hot. Because the path from the piston heat is to go to the cylinder wall via the rings and then to the water jackets. Having the second one there, it helps it cool. Okay? Because the second, the oil control ring is a low tension one. It wants to wobble. Okay, so 043, 1/16. And then you're looking at an oil pack there that's, but anyway. Now, where's my other one? Now here's the one for this head. Big Daddy. Same compression. Okay, I think that's the old Chevy, especially the big block. Probably has a what, 118, 123 cc chambers. That one there is 75. Look, isn't that beauty? Okay, lateral gas ports. But the crazy part is, people always say, oh, I like to soften the heads, meaning if they run it for nitrous, is they soften the combustion chamber here. They put like a little concave there to have some activity there on the combustion. That was a great idea, but I had something better than that. When I ran this one, look at what I have. Put this plate, look underneath. I softened it up on the piston itself. I did put it on the combustion chamber. I have the concave there on the piston. Not here. You could, if you have extra money, but what if you have to revert back to NA or nitrous and all that? So I put my softening of the combustion chamber in the piston. All right, so, and here the pin is all the way to the top compared to this guy here. Whoop. Look how high that is. Two different heights. This one will push the bottom of the piston going up. Since it's lower, it wants to wobble this way. Trying to go up, it wants to kick it sideways. This is, okay? And the top is going to be going like this. Not only did you split the combustion chamber, but the shorter rod will tend to do this going up, especially on compression. It wants to go up and start doing a shake and bake. Here, not going to happen, or a lot less, because you're pushing on the very top of the piston. So when you're pushing that high, instead of here, where it tends to, if your pin was here, it tends to go side to side going up on compression, and it wants to do this. You're pushing all the way up. And there you go. Anyway, that's just a short recap. And I hope I didn't forget anything more. I think I'm getting older. The more I forget is, hey, what's that old saying? The older I get, the faster I went. I still know how fast I've gone through the years. That has stayed with me. But some of these guys, the more the story goes, the faster they get. Okay, wait a minute. That guy didn't go that fast back then. But anyway, that's part of the hot rodding fairy tale or story. Anyway, please subscribe and like my videos so I can keep talking more about these things. And I hope we improve and get a better understanding that hopefully all of us make better power. And most of all, durability has to be added in there with power. You cannot have power if you don't have durability. It's going to be a short day, short weekend. You can't win races like that if you're not there at the end. Okay? Anyway, thank you very much, guys. Subscribe and like Ben Almeida. And I'll post another video, but this time the Ford Cleveland heads. Okay? Thank you very much. Bye-bye.